Hello, welcome to the Group 13 midterm demo. It will be comprised of three parts. First, we will show you actual footage of a demo of what functionality we currently have working, and then we'll give statuses for both the hardware and the software. And now we will start off with video footage of the current functionality we have implemented.
Hello, I'm Ryan Mikey, and I will now be demoing the various types of inputs that we have for this project. We are going to start with a desktop application. This is just an app that can run on a desktop. To do this, we first hit Find Windows to find Windows on the local network, and we hit this, and we can hit the Turn Window Off and Off button to actually change the state of the window, as we're seeing there. In addition to that, one of the inputs that we have configured is a website, which here, not too much to it as of now, but much like with the desktop app, we can turn this window on and off with that. In addition to that, we have a lovely sensor right here, which it's a proximity sensor. So if we, hang on a second. Yeah, if we move our hand in front of it, the sensor, the window will change its state. And lastly, the last current input that we have is a mobile phone that we can, as we saw, we are able to push buttons on this mobile app and it can control the state of the window. And that right now, those four different types of inputs are the current four inputs that we have for this project.
We will now follow that up with the status of the hardware for this project.
Hello, my name is Joshua Forrest and I will be giving a hardware status update for our project. First, we'll start with the prototype in PCB. As of today, we have a complete working prototype that was able to integrate the requirements for our project. It also was able to integrate the software, which will be talked about in another section. Both of these work fully and are able to control the blind exactly how we wanted to. We also have had a PCB designed that was shipped out to JLC PCB. They're a manufacturer in China. Um, they had already approved the design and is currently being shipped.
After the hardware status was recorded, the PCB has arrived.
Thankfully, we were able to get the size down from the full uh, uh, board that was provided to us by the university down to 3.5 inches by 3.5 inches while still maintaining all of our components and functionality. Here is a bar chart to show the progression for the different categories related to hardware. For the prototype, as I stated earlier, we have a full working version, so it is at 100%. We are also able to have the software tested on the prototype, which was also at 100%. We verified that it all worked with all of our activation methods. We also have the PCB at 100%, since we were able to design it and have it approved by a manufacturer. The chokehold right now that we were at is the PCB delivery and assembly. With JLC, they had told us we actually paid for 2 day shipping, which was a much higher price than the normal standard. And it should have been delivered today, 7/5. However, it won't be arriving until 7/12. We do have some contingency plans in place. We've ordered another set of PCBs from a US manufacturer, so it should get here in time in case anything else goes wrong with this supplier. Um, Moving on from that, our components for all of our PCBs, we've ordered multiple copies just in case. We have all the components with all spares, more than 3 times the quantity needed. Um, and then for the final assembly, this being the actual project with the frame and the film being assembled, we have designed the frame. We just need to finalize buying the pieces and the acrylic and wood and attaching that to the PCB. And as I said earlier, the PCB is the main choke point at this point for the hardware. The major challenges that have affected us so far are the uncertainty with the international vendors, mainly being JLC. The shipping time is really what has held us up the most. That has a large part to do with COVID and how it's strained the global supply chain. Um, the other part is the assembly of the service mount technology onto the PCB. We had hoped that we would be able to get this done relatively easily, but we've had to go with QMS. They're a local Florida vendor that's partnered with the university for some time. They assemble PCB for senior design projects. We've worked with Sam Hanna. He has helped us a lot so far. He's given us some good insight on where to get the PCB assembled and some backups. So once that's here, he's given us a 3 to 4 day time frame. Once we drop off the board with all the traces and the components, they should be able to turn it around for us. So on that front, we just need to make sure it's actually done and it works, which we'll be able to test relatively easily. And then the last challenge that is, of course, very common with senior design is the timing restrictions of the group. Not everyone lives in the same area. Uh, Out of our 4 group members, 3 of us work. One has an internship in Melbourne. The 2 other group members work full time. Our other group member is working on their masters, so getting everyone to meet on time is actually very challenging. But so far, we've been able to meet all of our goals, and we're actually working on stretch goals related to hardware now. So we're making good progress, and we should be able to meet the deadlines given to us for senior design too.
And lastly, we will finish it off with the software status. So, to start off the software status, we will begin with the software work completed. Most of the core functionality for the project in terms of the software is finished. We have successfully tested the input methods that include TCP network traffic, UDP network traffic, traffic over Bluetooth, and input from a proximity sensor. In terms of the various different types of clients that we're able to successfully enter or control the window from includes desktop computers, mobile phones, and web browsers, which web browsers run on pretty much anything. In terms of the core features that we have implemented right now for the software, that primarily boils down to remote control of the window and locating the device on a computer network without the IP address. That way, an end user can just connect to a computer network and the software will locate the window and allow the user to interface with it automatically. In terms of the work remaining for the software, a few features that we'd like to implement is configure network credentials via Bluetooth. That way, an end user will just be able to turn on the device, connect to it with his phone to specify, hey, connect to this network with this password, and the device will just be able to connect to the network that way. In addition to in addition to the aesthetics, right now we have functioning clients for, let's say, like a web browser, a mobile phone app, a desktop application. However, they don't look too good. They do work, but they don't look good. So we want to improve the aesthetic appeal of those. In addition to that, we will want to implement, implement input confliction resolution. In case if you have conflicting inputs, the software can effectively deal with it. And after that, of course, we have some reach goals, which currently include statistics about the usage, such as like, hey, Windows been on for X amount of time, and additional configuration options. In terms of the various types of challenges that we had with making the software, of course, the computational limits of the board has been proven to yield some interesting problems, especially when it comes to like amount of code that we can actually have on the board. Of course, the programmer, for most of the time that he is coding, is physically distanced from the device itself, so that yielded some interesting problems that we were able to overcome. And lastly, when you stare at terminals all day, every day, getting something that is actually aesthetically pleasing can be difficult, and that has ended the software status.